I'm Don Box. This is my good friend Steve Main. We're going to spend an hour or so talking about some web programming techniques. I'm using some bits that Microsoft would love for you to use. So, why are we here? Guy walks into a talk and says, I would like to know X. Here are the three things we're going to try and figure out by the end of this hour. One is, how do my programs use the web? By the way, the web exists. It's not a fiction, right? It's actually there, right? We're going to embrace it in this talk. And question number one is, how does my little lowly program sitting on my machine take advantage of this vast swath of programmable goop that's available over HTTP? Second question is, how does my little lowly program become part of the larger web so other people can take advantage of it? And then the third question, which should be implicit, I hope, is how do we do this in a way that allows us to get home by 5 p.m. every day? You know, we all love writing code, but we also kind of love having hobbies and a personal life. And honestly, those of you who are married, it turns out if you work too long on some of this stuff, people who actually work pragmatically will get home before you do, which is a problem. Bits. We're going to use some software. We're not going to start from whole cloth. We're going to start from some platform plumbing that we've shipped. A lot of the stuff we're going to look at has already shipped. A lot more of the stuff we're going to look at shipped real soon now, as in .NET Framework 3.5, codenamed Orcus, and I forgot to put quotes on that. I apologize. And a couple of things we're going to look at in this talk are things that are going to ship at a undisclosed time. We're going to look at some experimental goop, which we're actually releasing in CTP form real soon now, but the exact way it's going to become a production piece of software is undetermined. And I'll clearly identify which of the three buckets any given thing we talk about fits into. Great. So let's go ahead and just dive right in. So, what is the web? I'm a programmer. I want to write programs. What do I need to know to be able to be a good citizen on the web? There are many things I should know. I should read RFC 2616. I should read the specs on URIs, URLs, URNs, XML, maybe XML schema, probably XML namespaces. There's any number of specs I could read. And Steve and I have read pretty much, I think, all of them, including a variety of dissertations and other academic papers. But at the end of the day, we were looking for a tattoo, right? Because ultimately, if I can't put it on a tattoo, I will forget it. So the more we went back and forth on this, we came up with these three memes which we think capture the zen of what's going on here. Meme number one is, it's the URI, stupid, right? The URI is a central piece of the web. Hiding it or avoiding it will not get you to where you want to be. Embracing it may help. It may not help, but it probably is a good start. Get is more important than you think. We'll talk a lot in this talk about how get works and what the meaning of get is. And ignoring get leads to very, very bad things happening in your life. And we'll talk about some of the bad things that have happened to Steve and I from not paying attention to get. And then finally, formats matter. And we'll dive into this one a lot later on. Let's go ahead and just get started. It's the URI, stupid. If you take nothing else away from this talk, it is the fact that the URI is the center of the web, right? When you go to a web browser, what is that thing you type in the address bar? It's a URI. Seems very obvious, but turns out there's some subtlety. The web pivots on URIs. Why? Because they're easy to write down, they're easy to share, and they're relatively easy to compare, and we'll see why comparison of URIs is an important thing in the next little section. The hierarchical nature of URIs matches many, but not all, information models. And there's really two ways to think of URIs. Well, there's many ways, but there's two fundamental ways we'll look at in this talk. One is as an opaque identifier. That is, guy walks into a bar, sees a URI over here on the bar stool, and doesn't try to interpret it in any way, shape, or form. That is, yes, it has structure. Yes, I know there's a query string. Yes, I know there's paths, blah, 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 blah. I could give a flying hoot about that. I'm simply going to drop this into my URI machinery and have the right thing happen. That's kind of the opaque identifier aspect of URIs. And that's a very, very important application of these things. Turns out there's another way of thinking about URIs, which is equally valid, and in some scenarios is a better way to think about them, and in other times it's not. And that is as a structured expression, dare I say a structured S expression. That is, it is a lexical artifact that I can decompose using well-known syntactic rules for breaking apart the paths and breaking apart the query strings and the query string names, the variable names and the variable values. And I can decompose it and do all kinds of processing on it. So in that case, the structure is important, and I want to embrace the structure. And we'll see, depending on what kind of hat I'm wearing in a particular scenario as a developer, I may want to think of them as opaque IDs, and I may want to think of them as structured expressions. A simple rubric would be, if I'm on the server, I want the latter. That is, I want to think of them as structured expressions, because I'm effectively implementing the evaluator for that S expression, to use Lisp speak. On the client, I largely want to think of them as opaque identifiers. Occasionally, the opposite is true, but by and large, server cares about the transparency of the URI, client doesn't want to think about the transparency of the URI. Make sense? Okay. URI space is often infinite for a given server. Now, certainly, in the abstract, right, the URI is a sequence of bytes, and if we assume that it's an unbounded length URI, the URI space is in fact infinite. If we assume that it's bounded by, say, 4096 characters, there's still plenty of URIs to go around. We're not going to run out of them anytime soon. And in the abstract, it's true that they're practically, if not actually, infinite. However, if we think about a given server, they may or may not be. If I take a simple web server, like an Apache server or an IIS server, and I drop a simple static content file like foo.htm or foo.html, and I drop it in there and I have no other static content nor dynamic content registered for that web server, it turns out with respect to that service, the URI space is infinite. In fact, it's one. Right? There's exactly one URI that makes sense. Because remember, I said static content, so we're not going to deal with query strings. We're not going to deal with any extensibility off the path. Basically, you either give my base URI, whack foo.htm, or you don't. But the only thing I have a valid, useful answer for is when you say foo.htm. Other kinds of servers, and kind of the ones that many people like to write, have an infinite URI space. How do they get an infinite URI space? One way to do it is to take query string parameters. Another way to do it is to actually have the hierarchical path space of the application, again, itself be driven based on the state or the data that the service is fronting. So given this infinite nature of URIs, it would be good if we had some concrete technology to think about reasoning about and programming against the infinite URI space. And so convention over the past probably 3 or 4 years has been to have this template syntax where we can basically say, here's the shape or structure of the URI, and here's where the holes are. And the holes represent the potential infinity of the URI. So, oops, I'll go forward. Steve and I love philosophizing. You know, we have the steam bath in Building 42 where we put on our togas and, you know, sip sherry and talk about deep philosophical aspects of life. But we also get paid to write software. We get paid to do the other thing, too, in fact. When I joined, for part of new employee orientation, I got the robe, which was pretty cool.
They're nice robes.
They're very nice robes. But we also get paid to write software. So we have a great way of representing the finite URI in .NET 1.0. System.URI is a great way to program individual URIs. Right? It's a fine programming model. Is it the best programming model in the world? I don't know, but it's good enough. It works. And we've certainly worked the bugs out of it in 3 releases. we're introducing in Orcus, and I forgot to put an announcing slide in the deck, but I'm now announcing a new feature, system.uri template, which gives us a way of thinking of the infinite nature of URIs. So what a URI template does is it gets initialized with a string. The format of the string matches the Gregorio IETF note for putting holes in URIs. It's also the same syntax that's used by Amazon A9 search and a lot of other things. So we're basically embracing that syntax and adding two pieces of functionality besides giving you a place to hold the string. Having a place to hold the string is nice, but it's not all that interesting. There are two interesting operations I can do on a URI template. The first one is bind. And what bind does is it takes a URI template and a set of actuals, that is a set of argument values, and constructs a concrete URI that's finite with the actuals bound to the holes. And part of the binding is not just lining up the names and the positions. It's also doing things like URI escaping to make sure that the URI you get back is legal. This is a better way to work than doing string.format. Because string.format basically says, I sure as hell hope the strings you're passing me are already URI escaped and legal for URIs. URI template alleviates the need to do that because we just do it for you. URI template.bind is kind of an interesting piece of technology, and we'll use it very, very soon. Steve's chomping at the bit. The more rocket sciencey piece of this is URI template.match. What URI template.match does is it takes the template with the holes and an actual URI that purports to be in the space of URIs described by the template. And when you call match, what you do is you get back effectively a Lambda environment, also called a name-value dictionary, which has the names of the template variables hoisted out to a dictionary that are bound to the actuals that we found in the URI. And so there's an invertible relationship where I can call bind and then match, and I'll get back the same URI. Or actually, I'll get back the same list of actuals. So URI bind, template bind and match are the basic machinery for how we deal with infinite URIs. There's another piece of machinery we built in Orcus called URI template table. What URI template table does is it kind of does the obvious thing. It takes a collection of URI templates. That is, here are all of the templates for all of the URIs I care about in my service. And you run a single URI candidate through it, and we figure out, based on some pretty obvious rules, which of the URI templates was the best match to the candidate URI. And then we call match on that and give you back the environment. And we give you not just the environment, we give you a bunch of other information about how we parsed the URI, what things we matched, what wildcard paths were present, et cetera. All kinds of interesting details. Let's go ahead and take a look at an example. There's an example that's static, right? But, this is MIX, and, MIX is part of, I know we have to talk about the live platform. So rather than have static, dead code, let's look at some live code by having Steve actually code this up.
Right. Yeah, so let's go write an app that uses some URIs. How's that sound, Don?
That sounds great.
That sounds like fun. So, I mean, it wouldn't be a Microsoft demo if we didn't go check out the Microsoft stock price. I'm using a service here from finance.yahoo.com, which is kind enough to give me a URI that gives me back the Microsoft stock price. And it comes back in this nice little comma-separated value. Great. It's a URI. I can type it into a web browser.
Stop. Moment of silence. It's over 30.
Woo! Woohoo!
And I have to ask, so can you go back to the web browser? I love the web browser.
Yeah, I love the web browser too.
So I have to ask, Steve, rhetorically, albeit, so Yahoo has this web service up there just to serve up the Microsoft stock price. Is that the case? We're
no.
so important that we are such a leading indicator of the Dow and the S&P 500 and all that?
Sometimes we would like to think so, but it turns out there are other stock prices in the universe too, which, given that I know sort of the syntax of the URI structure, I can go cons up the stock price for Yahoo almost magically.
Wow.
Wow, just by creating a new URI. Right? So actually, let's go write some code that just plays with these things. So I'm going to write public decimal get stock price, right? And it takes a symbol. Now, in order to actually go do the URI retrieval, I'm just going to use a piece of bog standard system.NET code called web client.
Shipped in 2002.
Yeah.
Archaic by today's software standards.
New web client, right? And then I can say, it has this handy little API called download string. And it takes a URI, stock URI, right? And then I can say return decimal.parse, s.split.
And the format that the service was returning was a comma-separated value.
Yep.
So it's a CSV file. Right. So fortunately, again, bogstandard.net, we have the ability to parse comma-delimited lists, which was a very useful facility.
Which is great.
Called string.split, where we give it the delimiter. And we already have the symbol, so we're pulling out the value.
Yep. And so we can go display that in some UI that I've written in this tiny little Avalon app. Kind of looks like this. Come here, right? So I'm going to go wire up that refresh button. And then I'm just going to cons this up. I'm going to mix logic. Create a little instance of our business logic class here, right? Logic dot.
So on that form, we had an edit control called stock symbol. So we're just going to pull the symbol out.
Right.
There's an F.
There's an F, and I can't get rid of it. All right. So there we go. Hit F5 on this guy. And we build. All right. And so I hit refresh. And we come back and we get 3046.
Give it up for Steve Main.
All right. Yes. Hey, I can use URIs. Now, the one problem with this code right now, if I go back and I type Yahoo in, Yahoo is apparently at 3046.
Like I said, Microsoft is the
He's
leading
the center of
indicator.
the universe. Yes. Right. So let's actually go. Let's go teach our URI processing machinery here, back in MIX logic, a little bit about the structure of the Yahoo Finance URIs. So the first thing that I'm going to do here is I'm going to pull out the base address for the Yahoo service into a new URI. New URI. HTTP finance yahoo.com. And then I'm going to come up with, I'm going to use this new URI template class. URI template. And I'm just going to go take this part of the URI, put some quotes around it. And now to go from the static URI into a template, I'm just going to punch out this symbol here and replace it with some curly braces. Great? OK, so now instead of saying download string, I'm going to say stock template dot bind by position. All right.
We give it the base URI.
Stock base URI. And then I'm going to give it some parameters. And the parameter is passed in. Right? And that's the symbol. So this bind by position is just going to walk left to right across the URI template and just slot in values based on all the spaces it sees, all the places it sees curly braces in the URI template. All right? There we go. So we build and we have 5. Great. We see Microsoft. And 2803 for Yahoo.
Is that correct?
That is correct.
Great. Fine. Excellent.
Yep.
So that's one example. Mm-hmm. Are there other things we can do with URI?
Why, yes, there actually is. Let's go use this other URI that I have out there.
Okay.
So I have a URI to the United States government census service. And those guys are kind enough to actually expose out the current population of both the United States and the world behind a URI that I can go punch into my web browser. And this URI is kind of special because it comes back with a syndication feed. This is some RSS, which is why IE has kind of decided to go display it in this really nice, interesting way. And so the census, in the infinite wisdom of the United States government, has decided to take this rich format for structured data and tunnel everything through the title element. So we have to go grovel around with some XML and pull all this stuff out. But the data's behind a URI. So let's go.
Yes. At least the
URI is...
They did get the it's the URI stupid
yes,
memo.
exactly. They clearly were not paying attention to the other half of the talk.
Yeah.
All right, so let's go write...
Get populations?
Yeah, why not? Public. And that's going to return an array of longs. Right? Mm-hmm. Great, perfect. And in order, how are we going to get this back? Well, let's go use some xlink, right? So I'm going to call xdocument equals xdocument.load. And I'm going to pass it a URI, right? And that's going to be census, yes, toString. Great. Right, and then so let's do a query to pull all of those items out of there. An IEnumerable of x element, items, feed dot root dot element.
RSS? Oh, yes, channel.
Yes. Elements. Item, and that's going to give us, that's a simple little xlink query that's going to give us all of the item elements in the incoming RSS feed, right? Now, to get the title of the United States element, we have to go and find the title that starts with the string US. So that's pretty easy to do with xlink. I can basically say, from item in items, where item dot element title dot value dot starts with US, right? And then we basically say select item dot element dot title dot value. And then we'll pull out the first one of those because link returns us an IEnumerable. First, right?
Sweet.
Great. So we can do the same thing for the world. Just by changing the element that we're looking for, right? And then we're going to say return new. All right. And actually, I'm going to go pull in this little handy function that I've pre-rolled for pulling out the actual interesting values out of the title, right? So I'm just going to paste this in here. It's called
I've never seen that happen,
yes.
Steve.
Wow, well, it's
Had
beta
this
bits.
demo not crashed Visual Studio, which is Orcus, right? Pre-release software. Release software would never do this from Microsoft. Had this not happened, Steve would have pasted in the 4 lines of boilerplate regex code, which is just another piece of platform machinery. Sucked out the 2 longs from the title string and given it back to us.
Yep.
While Steve resets his machine, I'm going to move on to the next
That
step.
sounds like a great idea.
So, we saw URI templates give us a great way to think about URI handling. The second of these ideas we need to make sure we all understand is that GET is more important than you think. If you look at the way the web actually works, the vast majority of the internet traffic that does HTTP is HTTP GET. A very small minority of the traffic is everything else. And acknowledging that GET is special is the first step towards understanding how to take advantage of this stuff. What do we know about GET? Well, it turns out GET is nice because it gives us a very well-understood box to live in. It has very bounded semantics. GET always means the same thing, retrieve. Now, if you're a blue-collar person, you might say, get me some data. If you're a highly principled academic, you would say, retrieve the representation of a resource that I can never actually see, but I can view representations of. Doesn't matter, right? There are 2 ways of saying effectively the same thing. Go get me a structured value that corresponds to this URI. Other things we know about GET is that it has no unsafe side effects. That is, issuing it is generally considered a safe operation and will not cause the disk to be formatted. It will not cause a transaction to happen on the server that would charge you money or do other things that would be otherwise disconcerting. Another thing we know about GET, which is very useful and we can take advantage of a lot, is that there's a strong expectation of idempotency. That is, doing it once is the same as doing it more than once. Kind of like saying, I love you to your spouse. Right? It doesn't matter how many times you say it. Increasingly saying it over and over again does not seem to have any increasingly strong effect. That's at least been my experience. This does, and in fact, the expectation of idempotency is so deep in this, there's actually protocol support in HTTP to support when you aren't idempotent. Right? In an ideal world, GET would be pure. That is, it would be pure in a functional sense. That is, given the same input, which is the URI, you would always get the same output from now to the end of time. If the web worked that way, performance would go through the roof. Because caches could be uber smart and uber efficient, and we'd only have to talk to any given server once. And we could replicate the caches, and life would just be lovely. The reality is, often, the URIs are backed by things that actually change. Not the querying of them that changes, but the fact they actually represent real-world resources like files in the file system or stock prices or things of that nature. And so the web infrastructure, both in HTTP and the things that implement HTTP, gives us support for dealing with that idempotency through things like e-tags and if-modified since and all of the cache management that allow us to know and think about idempotency in a sane way. And GET gives us all of these things. It's great. I want to take advantage of that. I've said it a couple times. I'll say it again. HTTP GET is one of the most deeply engineered pieces of distributed architecture and plumbing that has ever roamed the earth. And I don't know that we'll ever get to that level any time again in our lifetime. Maybe we will. I don't know. But certainly HTTP GET is a thing, and you ignore it at your peril. However, what if my app needs to do things that don't fall into that bucket? Like, what if when you talk to my service, I actually want to charge you money or move money from one bank account to another or cause new files to appear in the file system that you would actually care about and want to see later on? Or maybe do things that aren't idempotent. That is, maybe I want to implement something that increments the stock price every time you ask me. And in that case, it's definitely not an idempotent operation. For this, we need a backdoor. We need an escape valve out of GET to be able to go do those things. Now, here's an interesting observation. I need both of these because the thing on the left gives me a lot of advantages in terms of scalability and just reach. The thing on the right I need to be able to have a complete closed system that I can actually build everything on top of. Because if I didn't have the outlet for chaos, the only way you could change the state that was being served up by GETs is through some out-of-band mechanism like sending an email. Right? That wouldn't be good. The interesting observation is when you have both of these, it's possible, and I'm going to plead guilty, to see, well, if I have the thing on the chaos side, you know, I could just put my bounded semantics into the unbounded semantics bucket and it would work. To be clear, it will work. It will just not work well. Right? Could I do gets over whatever mechanism I use for chaos? I guess you could. However, you're sanding against the grain. Right? You're leaving on the table this great piece of infrastructure and not taking advantage of it and using it to your advantage. So, this is the way the world works. Let's talk about the chaos. Well, in HTTP, there are various ways of thinking about the chaos. There is a set of reasoned and disciplined HTTP methods for dealing with updates. Delete and put are two HTTP methods that one can use for dealing with the chaos. However, they only capture a small number of the chaotic things you may want to do. They don't deal with things like buy a new car. Right? How do I implement buy a new car on my web server? Do I put to a particular thing? Do I delete a URI that represents an amount in my bank account? I suppose you could make that work, but ultimately, pragmatically, people want to be able to just say, do this arbitrary thing, and for that we have post. Now, people have tried to imbue post with all kinds of semantics, and that's a great thing. Right? In certain areas, they may have well-understood semantics. But as far as the plumbing is concerned, as far as HTTP itself is concerned, there isn't a lot of semantic meaning around post. It is your playground to implement pretty much anything you want. Now, you could implement get on top of post if you wanted to, but again, you're ignoring this fantastic piece of technology at your peril.
I don't know who implements get on top of post.
I know someone who implements get on top of post, and he's paying his penance. Right this minute,
Yes.
in fact. Yes. Many of us have tried to do get on top of post, and it works, but it doesn't work anywhere near as well as when you do get on top of get. What an odd concept. So, we can try and put more order over the chaos, but ultimately it's still pretty chaotic. So, how do I think about the relative importance of all of these HTTP methods? Steve, you wrote this next slide, so I'll let you speak to it.
Yeah. Well, there's a little bit of an existence, just sort of a mental exercise on the significance of what would happen. Like, imagine a world where suddenly, through some accident, some nuclear accident, the HTTP delete verb went away. The relative blip on the radar screen would be, I don't know, it'd be pretty unsubstantial, right? If you turned off put, you'd see a little bit larger problem, like we're kind of out of the smooth jazz realm at this point. Now, if you did the exercise again and imagine that something came along and suddenly post went away, all of a sudden, all sorts of things start breaking. You can't submit HTTP form posts, so all of your online banking goes away. You can't go off and add information to the internet. Now, if you turn off get, right, when you turn off get, literally the entire internet falls over. The entire web goes away. And so that's kind of one way to think about the existence, just the base intuition around these two really important verbs, one being do it, which is the get semantic.
No, post. You said do it.
Sorry, it's early. Yeah, one being view it, which is the get semantic, and do it being the post semantic.
Yes. So, without further ado, Steve, let's talk about some bits. So, what have we done to make it easier to do get? By the way, we have great support for HTTP GET in the platform. ASP.NET is our premier way of implementing HTTP GET and has been for a very long time. What we've done is a couple of things, though, to broaden the support for HTTP GET. One thing is we've trained WCF in Orcus to be able to deal with GET explicitly. And supporting GET doesn't just mean setting the HTTP method in the HTTP transport, which of course you can do that today. What the web GET attribute does in WCF is a variety of things. One thing it allows us to do is embrace the URI-ness of our service and actually use a URI template to specify the contract for a given piece of code. The template parameters get bound to actual method arguments, so you don't have to go do all that work. We also have made all of the webness and the HTTP getness available to us through this thing called the web operation context, which allows us to reach up in our server and get access to all of the things we might need to do to go implement get in a reasonable way. We also have web invoke, which is for the do it side of the world. And web invoke is for post, put, delete, and everything else that can have side effects and other chaotic things. And of course, in this world, post is the default method. But obviously, for folks who want to do, extremely restful things like implementing APP, it's trivial to use web get and web invoke to implement those things as well. Another piece of plumbing we're going to show you in a second here, which is new, is this thing called Web HTTP Client. WebGet and WebInvoke work great for the transparent URI story. Remember when we talked about URIs and we said two ways to think about them. One is an opaque thing like a GUID that you don't even think about the structure on, and the other one is where it's transparent. WebGet and WebInvoke work great on both the client and the server if you're dealing with transparent URIs, that is templated URIs where you know what the holes are and you want to fill the holes in. On the client, often we want to be able to deal with these things opaquely, and so for that we have an additional client-side programming model called Web HTTP Client, which supports both the transparent and the opaque scenarios. And it's much easier to use and more scalable than the current shipping web client APIs. So, without further ado, let's watch Steve code.
All right.
So, Steve, I'm confident VS has come back.
I have actually, yes, I have recovered from the tremendous copy-paste accident.
Great.
So the actual other end, that demo is working now. I'll just F5 it really fast.
So you're going to prove.
Just to prove to you that I wasn't making this up, I'm going to go off. And this right here is the current population of the United States, and this rather large number is the current population of the world. So now what we've done is we've just written some URIs, we've written some URI retrieval machinery, and now we have both the current Microsoft stock price as well as the population of both the United States and the world.
Yes. So given those two pieces of data, the Microsoft stock price and the number of people on the planet, what kind of app could we build? Because right now it's been a pure technology demonstration. I assert that if we had one more piece of data, which was the number of shares owned by a particular person on the universe, we'd be able to figure out how that person could take all of their Microsoft wealth and redistribute it in a philanthropic way to everyone in the United States or everyone on the planet.
What a great idea. It turns out that I actually have that number. It's right there, and it's something on the order of, wow, a whole lot more shares than I have.
Wow. So we know of one person whose worth is approximately that many Microsoft shares.
Yeah, I wonder who that guy could be.
Yeah. Great. Cool. So here we're looking at this function, which you just kind of wrote while I was blathering. And what this thing does is it goes out and conjures up a data structure called mixed data. Can we go look at mixed data real quick?
Yeah, sure.
So mixed data has 7 pieces of data in it. The stock symbol we use to go figure out these numbers, the stock price at the time we did the calculation, the 2 population numbers, that is the Earth and the country. So we keep these, the top 4 are really part of the sample information. The 2 contribution numbers are basically, if I took someone's numbers of shares times the stock price and divided it by the populations, how much would the redistribution look like? Make sense? So all this class is, all that class was a simple class with only properties, no methods, and an implemented data binding, so no big deal.
And it wears this great data contract metadata.
Yes, it's marked up so it's serializable, as we'll see. We'll see that later.
Yep.
Cool. So what Steve's going to do now is go monkey up this button handler in our Avalon app to go off and do get current data, giving it the stock symbol that you typed in the upper left.
Yep.
And so what this thing is going to do is call that function we looked at that does the 2 web service gets, does the data aggregation into this data structure and returns us the data structure. And he's going to slap a WPF control onto the form that we were looking at that will then render that information in a way that we can actually see it.
So this is just a content control.
So we have a new content control. It's got a name called current data. We're just going to set the content of that thing to the result of this web service query.
All right.
Great.
So let's go run that.
So we're going to go do the queries.
Yeah, it's running off. It's grabbing that.
And so now what we'll see is at 10:39 and 39 seconds, Microsoft stock was at $30.52. The U.S. and Earth populations were those, and basically if someone who owned that number of shares wanted to redistribute his wealth to everyone in the country, you'd be receiving a check for $193.35. If he decided to redistribute it to everyone on the planet, he would be sending everyone a check for $8.85. Right? I kind of like the first number better because I get more, but that's just the greedy bastard in me. Right? I guess I should be more altruistic since this is a very altruistic demo sequence, right? Because we're basically building a generosity clock.
Yeah.
Right? Great. Cool. So we've done that, and so far, all we've been doing is writing an Avalon program that's been doing HTTP gets inside the program and doing the work. What I want to do now is take that aggregation logic and then go expose that as a service. Because the problem is all the algorithms and the numbers and the stuff I use to go do all those calculations are now embedded in that client. And everybody who wants to do apps against this data now needs to have my DLL loaded inside their process. That's not a good way to go. I mean, it's an okay way. I'd like to enable that, but I don't want to require it. So what we're going to do now is use WCF to go build a HTTP GET-based service that will serve up the exact same data for anybody to consume.
Yep.
So what Steve's going to do is bring in, we've got a little project for building a service. So why don't you go ahead and go to MIX07.cs.
Yep.
And you'll see we have a very, very boilerplate piece of code here, which says I've got a class called myService. That's going to be where I put my code for my server. I'm in my main, because I'm just a little console app here, I'm going to basically create a web service host, giving it the type of the thing that I am, and I'm going to give it a base URI, which basically says I'm going to respond to all requests for this base URI and beyond. Right? So I've got an infinite URI space. Everything after the whack is mine.
Yep.
Everything on the left side of the whack belongs to somebody else. So what we're going to do now is go ahead and write a service operation.
All right.
So we're going to write a class, a method, public mix data. So we're going to basically go write that get current data function here. It's going to take a symbol, because we're going to allow you to look and see if only that person could trade his shares on a one-to-one basis for, say, Google, how much better would it be for the rest of us, right? And what we're going to do is call the same piece of logic. Oh, no, we're not, because you're not moving the caret.
No.
What we're going to do is tell Indigo, that is WCF, that we're actually building a get-based operation by saying web get here. And what we're going to do is we're going to take ownership of our URI space. Right? Remember, it's the URI stupid. That's another really important part of this story. So what we're going to do is allow the contract itself to specify how the URI projects down to my code. So what we're going to do is say if you go to whatever the base URI is, plus data, whack symbols, whack whatever, I will give you back one of these things. So what we're going to do is cons up the exact same little piece of code we wrote just a second ago. This time we're going to run it on the server, and we're going to surface it this way. Now, that's the server-side programming model. Simple, we write a method, we add the web get attribute, and it supports HTTP get semantics, blah, blah, blah. Now, what we're going to do is go alter the client to take advantage of this server.
Yeah.
So what we're going to do is get rid of this line of code altogether, right? That's all that client-side logic, screw it. Let's take advantage of the processing power of the server, right? So what we're going to do is call web HTTP,
Yep, I have to add a using Microsoft.servicemodel.web.client.
Great. And so what we're going to do here is cons up a web HTTP client. And we're going to set the URI template of the client to be HTTP : whack whack localhost whack mix whack data whack symbols whack open curly. And in this case, we're going to use positional variable names rather than symbolic variable names. And to be crystal clear, web HTTP client is not in Orcus. It's a piece of experimental plumbing. And we haven't aligned it yet with the syntax from the other piece. Great.
Right.
And what web HTTP client does is it gives us both synchronous and asynchronous ways to call get, post, put, delete, and do it in such a way that it's got the right extensibility points. If you want to do things like authentication or special signing on the way out, it's pretty easy to do it with this piece of code. The other interesting thing this does is it integrates with our serialization engines. So I can actually go say client.get, which gives me back the abstract entity body. And then I can apply whatever serialization scheme I want on top of that. So here what I'm going to do is basically say go do a get against that URI template, then take the result and run it through a deserializer that will shred it to mixed data. Make sense?
Yep.
And so now we got back the same thing we got before. And if we run both pieces of code, so the server's running, allegedly.
Yes, it's open.
Service is open.
All right.
Is the client running? Client's running?
Yep.
And now, hit the refresh button. Same exact functionality, except this time the logic happened over on the server, right? And dare I say, if you were to bring up a web browser of your choice.
How about IE?
Okay, IE would be fine. So we'll go localhost, mix, symbols, MSFT. Notice that that same data because we exported it using get as opposed to post, which is kind of the other way people write web services, the thing is now visible to a web browser. Okay? Make sense? All right. Flip back to the slides, please, my friend. Now, it's a miracle that you could actually understand jack about what came out of my service. Right? Steve wrote that service. It's a good citizen with respect to HTTP. You can do all the standard things you would expect to do with an HTTP GET. However, the thing we gave back wasn't all that interesting in Internet Explorer. It turns out when you think about why the web exists and why the web succeeded, it was about reach. And a lot of people correctly talk about the fact that the web was built on uniform operations. Right? When you hear these, REST versus other things debates, one of the things they trot out is the fact that there's a fixed set of operations. Right? Now, there's a very important fixed operation called GET, which was super fundamental. But the idea that you've got a fixed set of operations makes it a lot easier to combine arbitrary consumers with arbitrary producers, because at least the semantics of the verbs line up. Right? I know that everybody knows what this particular verb means. And if you're going to consume a foo operation and you're going to implement a foo operation, if I wire the two pieces of software together, I have a better chance of it doing something meaningful than otherwise. So having a set of uniform fixed operations is a great thing. It's definitely a significant part of the reach value prop of the web. Turns out it's insufficient. Right? The second half of this coin is that the formats that go back and forth on the wire also need to be uniform. That is, if all I had was application/binary, and all I was doing was shoving byte arrays back and forth, we wouldn't have this, kind of groundswell of momentum. Having common formats turns out to be a very important thing as well. Now, in the early days of the web, kind of the way the web got here, there was a ubiquitous format for doing UX kinds of things, right? And that format was, of course, HTML, and God love it. We'll be supporting HTML from now to the end of time, and it's a great thing, and I love HTML. However, for exchanging data between programs, we don't have a format, we have some formats. Now, there was a point in time where it looked like maybe we would have one format, which was XML. Right? And certainly if you read like the original Bosworth Sea Urchins paper and all the original, 96, 97 era stuff about when XML was born, right? XML was data for the web and it was going to be the thing. And that notion of having XML being spewed up typically via GET from these services was a great vision. Unfortunately, devil's in the details. A couple things happened along the way. One thing that happened was people started wanting to write JavaScript in the browser, and dealing with XML in JavaScript in some browsers is actually a fine environment. In other browsers, it's kind of tough. So obviously, everyone knows about JSON, which is another format which we sling a lot on the web, and increasingly slinging more and more of this nowadays. And so JSON was really kind of to deal with the fact we didn't have XML parsers in JavaScript. Right? Had there been great XML parsers in JavaScript, or E4X had succeeded and become ubiquitous, we might be in a different position. But we're not. Another interesting thing is unconstrained XML is only kind of sort of interesting. Right? Because arbitrary XML is kind of like arbitrary S expressions. It's like gray paste. Right? It's amorphous. It's shapeless. Yes, I can parse it. Yes, I can destructure it. But unless I know the meanings of some of the symbols that appear in the stream, there ain't a whole lot I can do with it unless somebody tells me about it. And that whole part of somebody telling me about it is the thing that inhibits the scalability. Right? Having a format that everyone has been told about already and then piggybacking on that turns out to be a pretty compelling way to go. We have a couple of constraints over XML. One of them is RSS and Atom, which are different but very similar. Both of them constrain plain old XML by adding a list structure to the XML document. SOAP is a different constraint over plain old XML that adds a header processing model. So, bottom line is, to go build software in this space, you have to be cognizant of what the format is. Be explicit about dealing with it and do a reasonable job, otherwise nobody will use your stuff. So, WCF, which is Indigo, and formats. So WebGet and WebInvoke, which are the two attributes we talked about a second ago, and that's the attribute we used on the server to enable us to cough up the stuff over HTTP GET. These two attributes both support XML, they support JSON, or they support opaque binary formats, so you can serve up JPEGs or whatever you want to serve up from your Indigo service, pretty trivially. You might say, where's the SOAP support? Well, guess what? We spent a lot of money building SOAP support in V1. And we think we nailed that one. Now we're trying to nail everything else, too. So SOAP and POX were in V1. We're adding support for other formats in Orcus. The specifics that we're adding that are kind of interesting are we're actually spending a lot on making it easy to get to RSS and Atom data as a format. So we have a rich programming model for dealing with feeds that can be used either standalone or as WCF message content. That is, I can have message parts that are Atom or RSS, or I can just use it as a standalone piece of code. And our syndication stack integrates with the rest of our serialization stacks so that when you want to be able to stick extensibility elements into your Atom feeds or your RSS feeds, it's pretty easy to do either as XML DOM or XElement or using an object deserializer. So, one last chance to code, Steve. This is your last gasp.
Oh, cool.
So, we saw what the app looked like when we looked at it from the browser. It didn't look all that interesting. What we want to do is do a couple things to the app. First thing we want to do is, right now, every time you ask me for an answer, I kind of forget it. I give you the answer and then I forget it. What we want to do is, we've got a little piece of machinery here in this sample app called IMDb, as in in-memory database. So what we're going to do is alter our function for get current data to, before we return the data to the client, we're going to simply add the result of the query to the cache. So we'll go ahead and do mixed data equals logic.getCurrentData, blah, blah, blah. We will then call imdb.add on the data, and then we'll return the data. So all we've done is altered our method that we wrote in the last little stanza of code to just add this one line of intermediate code, which is going to cache the result of the query. And we're just going to keep a running list of the answers we've given out lately, because we'd like to know, well, what are people thinking about donating money for, and where are they expecting to get it from? So the next thing we're going to do is give you the ability to point to specific cache entries. Right? Going back to this whole URI space management, we'd like to be able to put the results of our cache accessible to the URI getters of the world. So what we're going to do is write a second method called getCachedResult. And we're going to take an index, and we will then go get the results of the cache.
Yeah, let's go.
If sub I.
Great.
So the cache gives us an indexer, so we can go get the MRU list of results. And being good web citizens, what we're going to do is give this thing a reasonable URI. So URI template equals data whack results whack index. So you can now kind of imagine what the URI to go get the data is. And that's probably sufficient for now. Do you think so?
Yeah, I think so.
What happens if the index is out of bounds?
We throw a horrible...
Should we do something about that or not?
Yeah, I think we should do something about that.
Great.
Because would you say that this URI kind of identifies the resource, or sort of one way of thinking about the world might be in that way?
Well, certainly this URI may not be backed by anything interesting. We'd like to be able to say it's not found.
Oh, yeah, at the very
least. So why don't you go ahead and write that code?
Yeah, if I greater than imdb.contents.link. Right?
Okay.
So I'm going to use...
greater than or equal to.
Yeah.
Zero based. That whole
Thank
thing.
you for fixing my fence.
So if it turns out that we don't have what we want, we'll go ahead and go to web operation context.current.outgoing response dot set status is not found. And so what this does is it gives us a way of saying 404 in a simple, straightforward, and slightly more general way that we'll see later on. Great. So now go ahead and run the thing.
Right. Great. So
We have to do a query. Oh, I'm sorry. Go ahead.
well, let's just actually go grab the. We can get the query.
There's the Microsoft stock price. Do a Yahoo one.
Great.
Cool. Now go to data whack results, which was the URI template we used. Whack 0.
Do we have a?
We got a 404.
Yes.
Let's go look at that code. It couldn't be that there's a bug there, Steve. I cannot
No.
believe we have a bug. So if I is greater than the length, then do that. Else, return that. We added it to the length. Steve,
Yeah.
let's diagnose this bug after we write the next chunk of code.
That sounds like a great
Because
idea.
the next chunk of code will obviously reveal it in a different way.
Yep.
So had this demo worked, we would have coughed up another piece of XML which would have been equally stupid looking in a web browser. So what we want to do now is, of course, support a format that the web browser knows about. That would be RSS. So why don't we go ahead and write another method where we're going to serve up all of the cached results. And what we're going to do is let you tell us whether you want it as RSS, as Atom, or as some other funky XML format. I think for this one, all we need to do is implement RSS and Atom, and we're done.
Yeah.
In the interest of time.
Right.
So why don't we go ahead and go to our cache.
Sure.
So we're going to create a syndication feed. So syndication feed is part of Orcus. It's the way we deal with RSS and Atom data. So we're going to initialize the feed with the title, the description, and the URI, the standard things you see at the top of every channel or feed, depending on whether you're an Atom or an RSS guy.
Right.
Great. Close the constructor arg. Yes? Oh, no. Yes, you're
No.
right. Comma.
We're going to go add some items to this guy.
Yeah, so we've created the feed. Now we need to go do a query to populate the items.
Right. Right.
So what we're going to do is use link against our in-memory cache. So we're going to go find all the mixed data that we've produced. And what we're going to do is, as we iterate across that, we're going to map the mixed data, which is our local in-memory rep, to a syndication item, which is, of course, the item of an RSS or Atom feed. And we're going to give it some text, which will be somewhat interesting. Plus, here we go. Cool.
Right.
So Steve's putting the string, the data into some human-readable form.
Let's make it look pretty. Right?
Using really great HTML programming techniques.
Yeah. And stock price.
Great.
Yep.
Cool. And now we need to give it a URI. This is where we would give it the URI to get you back to the original data, which was that piece of code we just wrote, which I'm confident will work at some point in time. Notice here that when we cons up the link for each item, we're using the URI template machinery. So again, we're not hard coding in the URI construction, but we're using the mechanism we've already got. Cool?
Great.
And is that good enough? That's good enough.
Well, now, do you want to leave it there, or do you want to?
Well, let's do that and see if we can get that to work.
That's
Because we've had one demo fail so far, Steve. My demo karma is very low. So hold on. So that is the code that will cons up the RSS feed from the data we've already got. Yes?
Yes.
Now what we need to do is why don't we just pick a format?
Yeah,
Let's
sure.
just make this thing dirt easy. So let's pick, here's where you get to decide whether Microsoft is embracing RSS or Atom. Are you ready to make that decision for the entire company?
I am ready
for the next
right now.
5 minutes at least?
For the scope of this demo, we'll do Atom because it's alphabetically first.
Okay, great. Good, good, good. Cool. So what we're going to do is take that feed data and turn it into Atom format, and away we go. Do you think that's going to compile, Steve? I see red. Think you're missing some parens, dude. That looks better. Keep adding them until it stops complaining.
There we go.
There you go.
Man, it's just like Lisp.
You need. I take that as a compliment. Can you go to add a webget attribute to this thing so we can actually get to it from a browser?
Yeah, sure, why not? What URI do we want to get at?
So we need an operation contract, webget. And then what URI do you want to stick it at?
How about data whack feeds whack format?
Okay, you can give us a parameter to bind the format to? We already have it.
Yep,
Great.
we already have
We'll
it.
ignore the format parameter for now. It'd be easy enough to add the switch after we get it working. But damn it, I need to see code work, Steve.
Yep, me too. All right.
Run the server. Good.
All right.
So now just do a query. So do the symbols, data symbols.
Data symbols, Microsoft. Great.
Oh, are you doing Control F5 to actually on the other guy?
I think we're.
Steve, when you queried the symbol.
It doesn't look like your IDB class is sorting. That's why you're not getting it with the index.
You would think that, wouldn't you? Hit
Ah,
Control
yeah.
F5.
Remember how we were talking about how get enables caching?
Yes. Yes. Of course, the caching means we're not actually going to do the lookup. There we
Same
go.
problem there.
Wahoo! It worked. Cool. Now, this is great. However, what about our client app that we wrote a few minutes ago, right? The thing that was in Avalon. So we've spent this time doing formats that are known by the web so we can get them on the web browser. But in our client, remember before when we did that get current data and we visualized it in the Avalon app? Right, I wanted all the subordinate pieces of data, and I wanted to get to them pretty efficiently so I could easily data bind to them in my app. Right? I didn't want to have to go spelunking through a bunch of string parsing, which is what I had to do originally, which was the very first chunk of code I wrote.
Yep.
So why don't we do one more thing? Let's go back to the server. And remember, Atom and RSS both allow the notion of extension elements and extension attributes. So what we're going to do is just add an extension element to our feed. And what we're going to do is embed inside the RSS feed the mixed data that we were aggregating before. So remember, our cache of information is holding on to the actual structured, tight data. What we're going to do is embed that data inside the RSS feed. So let's get that working.
Let's do that.
Cool.
Semicolon.
You need the cache now. It's data. Dude,
Wow.
that's the bizarrest thing. We've put data in scope with from data in blah.
No, there it is. See, it really is just like Lisp.
Great. So why don't you go ahead and run the thing again. Go to the web browser.
Right.
Actually, go to the web
Let me
browser.
actually start my server here first, then we'll go to the web browser.
Go get the actual, do a few queries so we populate the cache. And you're doing Control F5s to make sure we're actually doing a read through.
Yep.
Great. Now go to the RSS, or do a Yahoo one.
Let's do.
Use your free will here. How about that? Great. Now do a view source. And do a wrap, format wrap.
Format, word wrap. Great.
So notice that it is a legal Atom feed. And it's completely consumable by any web browser that knows how to consume Atom. And we put in our own little micro format, which was our generosity data that we were calculating before. And if you look, just embedded in here is some additional XML, which we're going to go scrape out later on. Why don't we go quickly futz with the client?
We're going to go add that to the client. All right.
So what we're going to do on our client is when we do the refresh, that is when you hit the button, we're going to go off and also pull down the syndication feed. Scroll down.
Get all my Uniscope namespaces right.
So syndication feed.load takes a URI, and of course we could use URI templates if there were some interesting parameterization, like whether we cared about Atom or RSS. Turns out in this case we don't actually care. We're going to just cram in the URI that we need. Atom is fine, since that's the one we're supporting. Great.
Right. Perfect.
So we've got the feed. Now what we need to do is go spelunk through the feed. So we're going to go get all the items in the feed. And what we're going to do is select out the particular extension.
We got to give it a name.
By name. And by default, in fact, what it's going to take is the Q name. That is the XML Q name, which is just mixed data in no namespace. And away we go. So we basically pulled in the Atom data, walked through the items in the feed, pulled out the particular piece we want, and now we can take the result of that thing and data bind it.
So we can data bind it to a list view control here that I've already got kind of pre-rolled in my XAML file. I'm just going to go ahead and uncomment it. All right. That's just a list view that's going to give us some reasonable information and kind of a projection of the data that we're pulling out of the element extension. Right? So if I come back over here into mixwindow.xaml.cs in my code behind, I can just say feed control .items source equals result. All right. I'm going to go ahead and start my server. And I'm going to start my client. Click refresh. So this is going to go off and fetch the RSS feed. We hit it again, and we get the contents of the feed. So we're accumulating state on the server.
So you see a difference.
Oh, yeah.
The stock isn't that volatile, which I guess is good. Yes, there we go. Make sense? Cool. Flip back to the slides. Your monkeying days are over for this talk. Thank you, Steve. Cool. So what did we see? So we saw that we were able to program against the web, do the standard things with URIs and GET, enrich support for formats. In terms of what we showed you that's already shipped versus stuff that's shipping imminently, here's how it works. System.URI, we shipped that a hell of a long time ago along with web client. WPF and WCF, which we used somewhat in this demo, have shipped not that long ago. Stuff that's shipping in Orcus is URI template, WebGet, syndication feed, which is the support for RSS and Atom, all the support for link, including XML, and because we ran out of time, the JSON formatter. So the WebGet and WebInvoke attributes have a property on them that allows you to say whether you want the format to be in XML or in JSON. Unfortunately, we ran out of time. And then, of course, we looked at some very speculative bits, which is Web HTTP client, which we hope will show up in a very interesting vehicle very soon. In terms of mapping these new bits of bits in Orcus to the memes of URI stupid, GET, and formats, here's how the world shakes out. URI template is really about both URIs and about GET, because it's often used in a GET context. We saw we have a bunch of support for formats, and then WebGet kind of spans the whole thing and wraps it all into a bow, especially on the server side. Cool. So, Are there any questions about what we saw? So Astoria is built on top of the technology we just showed you. So web service host, web get, all of that stuff. That's actually, Astoria is just an application on top of that wires up the get methods and put methods to the EDM machinery, the entity machinery. Web HTTP client is the one piece of software we demoed in here. It was like 2 lines of code, which is not in Orcus because we couldn't make it in time for Orcus, and we'll find another ship vehicle to get it out there.
That
yes.
will.
I can hear you.
We've seen that this uncanny ability within the tech industry to take very simple stuff and make it complicated. I mean, we did the same thing with SOAP, and we have all these dependencies, and you need proxies, and you need all this crap on the server and stuff. And now it seems like we're taking some of the simple ideas behind HTTP GET and just piling a whole bunch of other stuff on top of it. Albeit it makes some things easier and stuff, but the consumption tax for this stuff seems to get huger and huger every single time. I mean, haven't we learned any lessons with this stuff?
Yes, we have learned lessons. To be clear, you can do HTTP GET programming on V1 of the platform. You didn't need WIDB. You didn't need any of this other stuff. There's an interesting balance, which is users ask us for higher level abstractions of ways to think about the world, like Ling. Right? People want to be able to think about query comprehensions in their programming language. Right? To be able to live well in that world sometimes requires new object models, right? New ways of programming. Same thing is true for XAML, right? A lot of people want to do things in XAML. Some people don't, but some people do. Yep. And so sometimes one has to write an object model that works well in XAML. I'll be honest, it's a tightrope. It's a very delicate balance of how do we just, we could basically take the Lisp approach and say, look, we gave you Car-Cooter and apply, go live the dream. Right? And everybody invents their own crap on top, which eventually people just build layers of crap. I mean, that's kind of the software industry. You're right. Yeah. That is the human nature of the programmer. Build layers of abstraction. The question is, do 1,000 customers build it 1,000 different ways, or do we take an attempt at least trying to get you there? Now, sometimes we succeed, sometimes we fail. Sometimes the layers of abstraction we build are actually pretty easy to use. ASP.NET's a great example, super easy to use, people really love it. Sometimes the stuff we build isn't as easy to use, like OLADB is my favorite example of a Microsoft technology that made COM look simple. Right? The observation is, look, we try, sometimes we succeed, sometimes we fail, right? The problem is, if we prevent you from getting to the bottom pieces, if we prevent you from getting to the equivalent of Car-Cooter and apply, then we've screwed you, right? None of the stuff we showed you in any way stops you from doing some of the simpler things below and building your own different artifices of crap on top, right? But fundamentally, by the time you want to take in like all of RSS and Atom, right, there's a lot of details in those specs, dealing with escape versus unescaped content, dealing with the way URIs get bound with relative and absolute. All that shit requires someone to write code to get it right, because it gives us one place where we can do interop testing and bake-offs. Right? Everybody can implement Atom and RSS today on top of the old XML stack we shipped ages ago. They can build on top of Xlink. In fact, the one place where the code got gnarly, the place where I winced when I watched this, was the syndication feed stuff. Right? When he wrote that link query, right, I can understand it because I haven't had my 2 beers yet today. But I got news for you. After my 2 beers, right, that's an ornate piece of code. Simply because, right, there's a lot of detail there that we want to give you the flexibility for. Could we do a better job at defaulting? Maybe, right? That's great feedback. I hear you. I love doing a better job with defaulting. But yeah, it's definitely a challenge. But the point when we stop giving you access to the lower level building blocks is the place where you really need to get worried, right? We're going to make these attempts at making stuff easier. Sometimes we're going to succeed, sometimes we'll fail. I think we did a pretty good job here. The syndication feed is probably the roughest piece of code we saw. And fortunately, we're only at beta 1. So this is great feedback. We'll obviously work to make it better. But yeah, it's just a risk of being a platform vendor. Really, it's tough.
Thanks.
Yeah. Yes?
Hi, Don. I wonder if you could comment a little bit on the history, the issues, implications, and the trade-offs on the fact that 10 years ago, let's say, when we first started using web services, we were just flinging around XML documents.
Yeah.
Followed by a period where there were various industry luminaries who were big fans of SOAP.
Yeah.
And now we've sort of come full circle and gone back again to flinging around XML and saying, well, SOAP is whatever.
Let's be clear. We could have easily put a SOAP wrapper on any one of these pieces. right? We just didn't.
So what's the guidance for us? In other words, you look at the different web services, software as a service that's out there. Some people are going with the flinging around XML approach, the REST approach. Some people using SOAP.
It's who you want reach to, right? Why did we had XML data, right? We had the mixed data, right? That little thing. It showed up in the browser, and yes, by some definition, we got browser reach, right? But the XML was just like in the default style sheet for XML was not all that useful, right? We wanted reach to users who use browsers, so we wrote the RSS GUI. If I wanted to do things like digital signatures, message level security, right? I'll tell you, I would have put a SOAP wrapper around that thing in a heartbeat. Turns out I didn't need message level security, so I didn't need the facilities I got with SOAP. If you think back to like all the evolution of how we got to where we're at with SOAP, the biggest two things I would change about history, because I think there's some implied question there. One is I would have been much more cognizant of GET up front. Right? When Dave and me and Bob and Mosin wrote the SOAP spec in '98, right? We used post because it was the unbounded semantics, right? It wasn't clear that there was this value in the bounded semantics, and we got the message. We heard you all, right? You were right, and so obviously we're working very hard to make sure we're good at that as well. Second thing though is, in a world where the SOAP envelope has no headers, it adds no value. We should have made the SOAP envelope optional when you have no headers. Had we done that, it would have been much more obvious how people could have gotten a linear complexity curve. Right now is, if you say you support SOAP, you have to sign up to do the envelope and the header processing and all that stuff. We didn't give you a good linear curve there.
All right, thanks.
We can solve it with software, but in terms of the specs, it's done. Yes, I hear you. One last question.
Okay. I've been playing around with some of the various REST services, and I've kind of had the exact opposite of experience. I guess the first question poser there. I'm wondering how flexible your URI template class is, because what I found is there's a lot of different ways to construct REST queries. A lot of times you've got different parameters, like for example location. You might have latitude and longitude, or you might have full address, or you might have city-state, that sort of thing. And there's others that actually will build it into the URL of your query, not using query string, just like slashes.
So, great. So we support both query string and path tolls. So it's up to the guy who designs the URI how he wants to structure it. And certainly when you're talking to somebody else's service, they've probably documented how they construct their URIs. You can drop in things including path wildcards. So I think we're pretty flexible there. I think we're pretty much feature compatible with the Gregorio IETF node. And of course, the place where we fall down, you construct the URI by hand, right? There is always the escape hatch. The interesting thing is on the service, you can write a whole bunch of web-get methods that have a variety of different, potentially overlapping URI schemes, right? And we just do the dispatch logic based on best matching. We document what the algorithm we use for selecting 1 out of n templates that would match the same candidate URI. So in terms of writing a service and giving, kind of having lots of different ways of coming at it from the URI space, I think we're pretty good at doing that too. But you should download the bits, which are on the web.
Coming
now.
very, very soon.
Yes.
Okay.
And let us know.
Thanks.
It's only beta 1, so now's a great chance to tell us how we suck, and we'll try and fix it. Our goal is to suck less every time. That's all you can do as a platform vendor.
Right.
Great. One last thing. We're holding a little private design review of some of this technology later this afternoon and tomorrow. It starts at 3:30. We have a couple of open seats. If you see this man over here, Clemens Basters, let him know you want to come, and maybe he can squeeze you in. One last word, Savas, or were you just saying goodbye?
No, it was a question, actually.
Savas, you should ask the last question, please.
So again, back to the web services and the plain XML over HTTP. You both guys know that allow the loose coupling over the interpretation of data. But over the years, we've grown up the idea of sharing data and metadata, and sharing contracts, and doing contract-based development. What you've shown us today is Microsoft suggesting that we move away from that model, since I shouldn't see any contract stuff.
Dude, do not overread. Look, there's a class of users who believes in metadata, who believes in contract enforcement, who believes in static typing, right? We've been sucking up to those guys for a long time, and I think we're doing a pretty good job making them happy. Can we do better? Yes, we're going to do better every release, right? But certainly, if you look at the last, I don't know, 10 years of Microsoft platform evolution, it's been around having static typing, right? COM, IUnknown, strongly typed, statically enforced, blah, blah, blah. .NET, the CLR, statically typed, blah, blah, blah. What you're observing, hopefully at this mix, but also just in general, is there's a group of people who don't believe that stuff. And you know what? It's a big tent. Microsoft has to make, has to satisfy a large user constituency. And we haven't done as good a job dealing with the folks who don't believe in metadata, who don't believe in static typing. So the stuff with the DLR and the Ruby and all that stuff is one data point that we need to address that constituency. The fact that a lot of web services, the only metadata is in HTML and the user reads it. Yes, or they read they basically read what the URI and result space looks like, and then they code against that, which is effectively what we did in this example. It's a valid way to program, and honestly, I like programming that way, and there are times that's really what I want, and so I'm glad the platform's evolving to make it easier to do those kinds of things, and not force me to go write a type up front and write a schema document up front and all that other stuff. There were a couple other features which were we couldn't get working on Steve's Frankenbuild box that would have made that picture point even more. Basically, we're making it easier for you to go to the Flickr webpage that just says, here's kind of what I do, you'll figure it out, and then go take that artifact and translate it into your code. Right? The URI templates is one piece of infrastructure we're building. We have a couple other things that basically Steve's box is kind of broken, if you couldn't tell from the couple of the demos, that would have been even more compelling. And I hate to cop out like that, but yeah. So no, we're not suggesting you move away. What we're saying is we're going to stop trying to change you. Right? We're in a marriage. Right? We had a couple months early on in the marriage to try and change each other. It ain't going to happen. Right? So let's just learn to live together for the sake of the children. Okay? Great. Thank you.
All right.